friends, welcome to another episode of Decluttered. In today's episode, let's understand why the transformation of axes actually work. So, we have our original x-axis and y-axis, and we were considering a transformed x-axis and a transformed y-axis. They need not be perpendicular to each other. If I consider an area vector in my transformed axis as this parallelogram given by dxt and dyt vectors, I know that the area vector in the transformed axis is dxt cross dyt, right? Now, I also know that xt is a1x plus b1y, yt is a2x plus b2y, which will mean dxt is a1 dx plus b1 dy and dyt is a2 dx plus b2 dy. So far with me? And now when I do the cross product, given that dx and dy, which is in my original frame of reference, are perpendicular, I will get dxt cross dyt, which is my transformed area, is a1 dx plus b1 dy cross a2 dx plus b2 dy. And when I'm doing cross product, dx cross dx is 0 because they are parallel, which will give me a1 b2 dx cross dy minus a2 b1 dx cross dy. That became a minus sign because I have b1 dy cross a2 dx, and we also know a bar cross b bar is minus of b bar cross a bar. So this will give you dy cross dx is minus of dx cross dy, and that minus sign is what I have brought, which is equal to a1 b2 minus a2 b1 into dx cross dy is A transform, and this part is actually the area we wanted, which brings us to area is equal to the transformed area by magnitude of a1 b2 minus a2 b1. And I'm considering that magnitude sign because typically we take areas as a positive quantity, but when we are looking at areas in vectors, if the area vector is coming out of the plane, it's a positive quantity. If it is going inwards, it's a negative quantity, and that's why this can be positive or negative. But when we are calculating areas, we eliminate that by taking the mod sign. I hope this clarifies as to why it works. Now, the condition that we had stipulated is xt should be equal to a1x plus b1y. That is, it works for a linear equation. It doesn't work when it is a function of x and a function of y, because when I differentiate, the derivative is not a dx dy. I have to apply chain rule and say dxt is a1 f dash of x dx plus b1 f dash of y dy. And when I cross multiply, unlike here when I could take a1 b2 and a2 b1 common, I'll not be able to do that if it is not a linear equation, and that's why this concept could not be used directly if we were transforming it, provided it's not a linear equation. I hope you liked this episode. If you did, do like, share and subscribe to our channel. and come back to us for more such interesting funda concepts.